So this is what we're going to be talking about. We're going to go into fractions and then also factoring. We're going to be doing some graphing. So that's going to be talking about like where two graphs will intersect. And then we're going to look at some trigonometry, SOHCAHTOA, of course, radians, special triangles, some trig identities. And then we'll look at some log rules and then some exponentials. Okay, so we'll go into fractions and factoring. So some basic terminology. You guys probably already know this, but just in case. So these are the denominators of each of these fractions. And these are the numerators of each of these fractions. So that would be the one on the top half of that fraction. These are proper fractions, and reason being is because the numerator is less than the denominator. These are this is an improper fraction because obviously the opposite is true. The numerator is actually larger than the denominator. And this is a mixed number because we have a integer at the front here. This occurs sometimes too. These two are termed reciprocals of each other. So if someone asks you to take the reciprocal of 5 over 11, well, the reciprocal of that would be 11 over 5. So just in case someone asks you about that. So multiplying fractions, we have 3x, and we're multiplying it by 5x on the top half of both of these fractions. So you just do 5 times 3, which is 5, 10, 15. And then on the bottom here, it would be 7 times 3, and that would be 21. And then this x, you just multiply x by x, and you get x squared. For a different example, if you were to do like x times x squared on the top half here, that would be x to the power of 3. And we'll get into like how exponentials work in a few minutes here. So dividing fractions, this kind of looks weird. So it's always better to put it into this simple fraction right here. So 6x over 7, all divided by 5x squared over 3. We have the same thing as 6x over 7 divided by 5x squared over 3. And then some tricks that you probably learned in high school is that you can take the reciprocal of this second fraction, and then all of a sudden this division becomes multiplication. So 6x over 7 divided by 5x squared over 3 is equal to 6x over 7 times 3 over 5x squared. And then you just multiply the tops. 18x is the top half, 7 times 5x squared is the bottom half, and then we have 35x squared. And so you can just reduce the x's here. X divided by x squared is 1 over x, so 18 over 35x. So adding fractions with common denominators. So right here, if you guys want to give this a try on your own, I'll give you a few minutes. And if you don't know how to do it, we'll go through it in just a minute. So basically, we're just trying to simplify this so that it's under one denominator. So we're trying to add these two fractions together. Okay, hopefully you guys had a minute or two to work on that. So what you would start off with, you would notice there's a 5y on the denominator here, and then there's a 4x on the denominator here of these two fractions. So to make them common denominator, you would multiply the top and the bottom of this fraction by the other fraction's denominator, if that makes sense. So now we have 4x times 3 on the top, 4x times 5y on the bottom. And then for this one, you would just do the opposite. You have 5y on the denominator of this fraction. So to make them common, you would do 5y on the top, 5y times 9 on the top, and 5y times 4x on the bottom. And then multiplying these, you would get 12x because 4 times 3 is 12. And then 45y for this one over here. 5y times 9 is 45. And the y stays the same. And then on the bottom, of course, you have 4x times 5y, and that's just 20xy, because x times y is xy. And then now these share a common denominator, so you can just combine them. 12x plus 45y over 20xy. Okay, so expanding and factoring equations. So we have y is equal to bracket x plus 4 bracket, and then x minus 6. So my teacher in high school taught this as feed the chickens. So you would do the first term and multiply that first term by each of the other brackets terms. So x times x is x squared. X times negative x would be negative x, or 6x here. And then 4 times x is plus 4x. And then 4 times negative 6 would be negative 24. And obviously it doesn't matter which order you did this in. I did it in the order of x times x squared and then 4 times x. And then I went around to the other side, but it really doesn't matter. If you do this feed the chickens method, it's quite a nice way of expanding. And then simplifying, you just do 4x minus 6x, and that's just negative 2x. So factoring equations. So y equals x squared plus 3x minus 40. We're going to be trying to factor that. We look at each of these terms at the front. So this one obviously has a 1, this one has a 3, and this one has a negative 40. And then we have to do this aside question here. So what two numbers multiply to equal negative 40, but also add up to make positive 3? So I got lucky here on this first attempt. We're going to try 8 and negative 5. So what two numbers multiply to equal negative 40? We can do 8 times negative 5. 8 times negative 5 is negative 40. And now if we try to do 8 minus 5, you get positive 3. And you notice that this red term here is not highlighted in this side of these notes. And that's because if there's a 1 in the front, it doesn't matter. But if it's a different number, which we'll see shortly, it does matter. And that would just be whatever term here would just be multiplied by negative 40. But so it's just a 1, it doesn't matter. So this works. We got 8 times negative 5 equals negative 40, and 8 plus negative 5 equals positive 3. So then we can do y equals x squared plus 8x, because we have an 8 here, and minus 5x, because we have a negative 5. And then minus 40, of course, that doesn't change. So all we're doing is changing that positive 3x into something that's still positive 3x, but now kind of expanded. So yeah. So now we can factor out some things. We have an x that we can factor out from these two terms here, and then we have a negative 5 that we can factor out from these two terms here. So then y equals x, bracket x plus 8, minus 5, x plus 8, because we're just factoring out those two terms. And then finally, we can factor out the x plus 8 on both sides of these terms. So now x plus 8 is just at the bottom here, and then we have our x minus 5 as the other bracket there. Now we're going to look at this one, which is slightly more difficult. And reason being is because now that red term is 2. So we have y equals 2x squared plus 7x minus 15. So again, we have an aside. What two numbers multiply to equal negative 30, which is 2, which is that red term, times by that negative 15 term. But then they also add up to make positive 7. So this took me a few attempts. We could try negative 5 and 6, because negative 5 times 6 is negative 30, which satisfies the first part. But we also have to add them up to make them equal positive 7. But in this case, it equals 1. So if you find that you try 5 and negative 6, again, it's negative 30. We're just switching around the negative, but that's equal to negative 1, so not quite what we want. We can try negative 3 and 10. Negative 3 times 10 is negative 30, and negative 3 plus 10 is equal to 7. So that's what we want. We could also try 3 and negative 10, but we would see that this would equal negative 30, but it wouldn't be positive 7, it would be negative 7. So you got to make sure that you have the negative in the right term in this case. So we got positive 7, so this works. We can try to expand that now. So we can have y equals 2x squared minus 3x plus 10x minus 15. And then we have, which is just positive 7x expanded out, right? Because we have negative 3x, and we also have plus 10x. And then negative 15 just stays the same. Factoring out that x again, and in this case, we factored out the 5. So x in brackets 2x minus 3 plus 5, and then 2x minus 3. So then we have y equals x plus 5 and 2x minus 3. And I have eureka here, so it's pretty satisfying once you get that. A nice quick check to see if you guys got the right answer is that these brackets in here, 2x minus 3 and 2x minus 3, should be the same ones. So to make that happen is if you were to factor out a 5 out of each of these terms. Because once you get those brackets the same, you can actually factor that out, right? Like how we did last time. And then the x plus 5 is in this bracket, and then the 2x minus 3 is in the other brackets. So difference of squares, we have a to the power of 2 minus b to the power of 2 is equal to a plus b and a minus b. So this is just a short way of factoring, but it could only happen if this is a square and this is a square. And it has to be, obviously a difference of the two. And so here are some examples: 9x squared minus 16, or this is just 3x to the power of 2, right? Because 3 times 3 is 9, and x times x is x squared. And then 16 is just 4 squared. And then using this formula, we can do 3x plus 4, because our a term is the 3x, and then our b term is the 4. So then 3x plus 4, and then 3x minus 4 is the answer. And then again, just another example here that you can look at. Okay, so applying this again, so we have x squared minus 4, which is the same thing as 2 to the power of 2. And then on the bottom, we have x minus 2. So using that formula that we have at the top right here, we can see that x plus 2 in brackets, then x minus 2 in brackets is what we get from this, because our a term is the x, and then our b term is the 2. So then x plus 2, and then we have x minus 2 as the factored equation. And this is all over x minus 2, and that actually works out quite nicely because we can cancel out the x minus 2 and the x minus 2, and we get x plus 2. And then this one is called difference of cubes. So we have a cubed plus b cubed as a potential question, right? And this would be our equivalent equation. So we have a plus b, and then we have in brackets a squared minus ab plus b squared. And so obviously this would have to be a cube and this would have to be a cube in our equation there. And then these would have to be the same signs. Obviously, if this was a positive, this would have to be a positive. If this was a negative, that would also have to be a negative. But as long as you know that the opposite sign would be for this equation here. And this is always going to be positive, that other term there. So yeah, we have that same kind of formula on the top right here, because we have an x cubed here, and we also have a minus 8, which is just 2 cubed, right? So that we have x minus 2 in brackets, and then we have x squared plus 2x plus 4. And then luckily enough, we have x minus 2 and x minus 2 cancel here to equal x squared plus 2x plus 4. And we see that this green and this green are both negative. We're keeping that consistent. And then this one's actually positive because we're taking that opposite sign. Our a term is the 1 in front of here, which, well, it's just the x actually. And then for this one, it's the 2. Or for b, it's the 2. So this is our a term. This is our b term, which is just 2. Then we have x squared. In this case, it's a negative, so we have to have the opposite sign for that. So instead of negative for that formula, we have positive, and that's why it's red. It's because it's the opposite. And then 2x plus 4, and that's always going to be positive there. I'll give you guys a second to look at this. Same sort of thing, but now we have a positive. So I guess this wouldn't really be called a difference of cubes. It would be more so like a addition of the cubes, but it works. The same formula works. So here are some sample questions. Try and factor these. So we have for a, x squared plus 3x plus 9. For b, we have x plus 4. C, we have x plus 2. And then for d, we have 3x plus 1 in brackets, and then x minus 2 in brackets. Awesome.